dig into the incredible, and often totally invisible, engineering that literally keeps our world from falling apart. Okay, just look at this thing. It's a retaining wall. You see them everywhere, lining highways and roads. And it looks pretty simple, right? Just a bunch of concrete blocks stacked up. But that wall is holding back an unbelievable amount of pressure. Thousands and thousands of tons of soil pushing against it day in and day out. So how on earth does it not just explode outwards? Now, you might be thinking it's just super thick, heavy concrete. But the real answer? Oh, it's way, way smarter than that. And it's hidden deep inside the dirt itself. Yup, you heard that right. The real hero here is layers of high-tech synthetic fabric. So today, we're going to unpack how engineers use these materials, they're called geosynthetics, to basically stitch the earth together. We're talking about building structures that not too long ago would have been considered pretty much impossible. So to really get why this fabric is such a massive deal, we gotta start with a basic challenge that engineers deal with constantly. And that is, the ground beneath our feet, it's not always the solid, reliable foundation we'd like to think it is. You know, for the longest time, if you needed to build something on soft, weak, or just unstable soil, your options were not great, and they were super expensive. You either had to dig out all the bad soil and haul in good stuff to replace it, or you had to design these incredibly complicated and pricey deep foundations. You just knew there had to be a better way. And, well, there is. The modern solution is to stop trying to fight the soil and actually start working with it. Instead of just replacing it, engineers figured out how to reinforce it, turning the ground itself into a crucial part of the structure. It's pretty brilliant. And using these materials, these geosynthetics, was a total game changer. All of a sudden, projects got way cheaper and you didn't need as much space. Since the materials are made in a factory, the quality control is amazing. And all of that leads to faster, more efficient construction with a much smaller environmental footprint. It's a win-win-win. Now, the workhorse of this whole revolution is something called a geotextile. Think fabric, but forget about cotton or wool. This stuff is made from seriously durable synthetic polymers, like polypropylene. It's porous, so water can get through. And it comes in different styles. Some look like felt, others are strong woven sheets, and each one is designed for a specific job, whether it's reinforcing, filtering, or separating soil layers. Then you've got its close cousin, the geogrid. It's basically a plastic net with these big openings. And those openings, engineers call them apertures, are the whole point. They let rocks and soil poke through and lock right into the grid. This creates this incredible interlocking force, giving the soil a kind of strength, tensile strength, that it just doesn't have on its own. It's what keeps it from being pulled apart. And then you've got geocells, which are just amazing. Picture a three-dimensional honeycomb structure. When you expand it and fill it up with soil or gravel or even concrete, it confines that material. It keeps it from spreading out. And that simple act of confinement makes the ground incredibly strong and stable. Okay, so we have these incredible materials, but how in the world do you actually use them to build a wall? I mean, we're talking about something made out of what is essentially just fabric and dirt. How does that work? Well, the result is what engineers call a mechanically stabilized earth, or MSE wall, and they come in all kinds of shapes and sizes. The part you see on the outside, the facing, can be concrete blocks, wire mesh, or even systems designed so you can plant vegetation right in them, making the whole wall blend into the landscape. But behind that facing, the principle is exactly the same. The way you build one is just brilliantly simple. First, you lay down a sheet of geotextile, but you leave some extra hanging over the front edge. Then you put a layer of soil on top and you pack it down tight. After that, you just fold that extra bit of fabric back over the top of the soil layer, kind of locking it in. And then you just do it again. Lay, backfill, fold, repeat. You just keep going layer by layer, building up this solid, internally reinforced block of earth. Okay, so the process looks simple enough, right? But believe me, behind that simplicity, there's some really serious engineering science, making sure these walls are safe and are going to last for decades. So here's how the physics works. Engineers know that if a wall like this were ever to fail, the soil would try to slide along a predictable curve. So they divide the soil into two zones. The part that wants to slide away is called the failure zone. The part that would stay put is the effective zone. The genius of it is, the geotextile only has to be long enough to stretch past that potential failure line and get a good grip inside the stable soil. The friction from the dirt above and below it does the rest, holding it tight. And, of course, there's math to make sure everything is safe. Engineers start with the ultimate strength of the fabric that they test in a lab. But they never just use that number. Instead, they apply a whole bunch of reduction factors. These account for things that can happen in the real world, like damage during installation, the slow stretching or creep that happens over many years, and even breakdown from chemicals in the soil. It's a super conservative approach that makes sure the wall is safe for its entire life. So, reinforcing soil is obviously a powerful tool for holding back slopes. But that's not the only problem geotechnical engineers face, right? What happens when the challenge is something completely different? Well, it just goes to show you that engineers have a whole toolbox for dealing with the ground. For an unstable slope, like we've been talking about, the solution is to reinforce it. But what about crazy vibrations from a giant industrial machine? You can't reinforce that away. The solution there is to isolate it, using special foundations to absorb that energy. Or what if you just need to hold back water at a construction site? Well, then you block it by driving huge interlocking steel sheets deep into the ground. Different problem, different tool. And all of this really brings us back to our main idea here. A lot of the time, the most clever, most important engineering is the kind you can't even see. It's working silently right under our feet. This quote just nails the whole concept. With these reinforced walls, the very thing that's creating the problem, that lateral pressure from the soil, is also being used to solve the problem. The fabric just lets the soil use its own weight and friction to hold itself up. I mean, how elegant is that? So the next time you're driving and you see one of those massive retaining walls, you'll know. You'll know its real strength isn't just in the concrete you can see, but in those hidden layers of fabric inside. It kind of makes you wonder, right? If we can engineer the earth itself to be stronger, what other kinds of invisible engineering are out there, quietly making our world possible?